How does the psychrometric saturation line work? Have you ever wondered how air can hold moisture and what happens when it reaches its limit? Let's break down the concept of the psychrometric saturation line and its role in air conditioning systems. The psychrometric saturation line indicates the point at which air is fully saturated with water vapor. This means the air has reached its maximum moisture capacity for a specific temperature and pressure. On a psychrometric chart, you will find this line curving along the upper left edge, marking the point of 100% relative humidity. When air reaches this saturation line, the dry bulb temperature, which is the air temperature you measure with a thermometer, equals the wet bulb temperature. The wet bulb temperature is what you would measure if the air were cooled by evaporation until it became saturated. If the air continues to cool beyond this point, moisture will start to condense out of the air. Understanding this concept requires a few key terms. First, dry bulb temperature is shown on the horizontal axis of the psychrometric chart. Next, relative humidity is the ratio of the current moisture content to the maximum moisture the air can hold, expressed as a percentage. The saturation line corresponds to 100% relative humidity. Another important term is dew point temperature. This is the temperature at which air must be cooled to become saturated and begin condensation. On the saturation line, the dew point temperature aligns with the moisture content of the air. As the temperature of the air increases, its ability to hold moisture also increases. This is why the saturation line curves upward on the chart. If you cool air while keeping the moisture content constant, you will move horizontally left on the chart until you reach the saturation line. This indicates 100% relative humidity and the dew point temperature. In practical applications, especially in heating, ventilation, and air conditioning systems, the saturation line is essential for engineers. It helps them determine when air will reach saturation and condensation will occur. This is crucial for controlling humidity levels and preventing issues like mold or corrosion. Additionally, the saturation line is used to analyze cooling and dehumidification processes. Cooling air below this line effectively removes moisture from the air. Engineers also use this line to calculate enthalpy, which is the total heat content of the air, and the energy requirements for heating, cooling, humidifying, or dehumidifying air. Sizing and selecting equipment such as air handlers, cooling coils, and humidifiers also relying on understanding the properties of air and moisture loads. The psychrometric saturation line clearly defines the maximum moisture air can hold at any temperature. It marks the threshold where condensation begins, making it fundamental for managing air properties in HVAC systems. This ensures comfort, energy efficiency, and reliable system performance.